1 mole of ideal gas is initially at 900 Kelvin. It undergoes a process 1 in which its entropy is constant, which means the change in entropy is the heat that is reversibly transferred at temperature T. This is 0, which means dq is 0, which means the process 1 is adiabatic. And in the case of adiabatic process, from the first law we know that the heat given to the system plus the work done on the system is reflected as a change in its internal energy. dq is 0, so the work done is the change in internal energy. So final internal energy minus initial internal energy. So from the graph we can see that final internal energy is U by R values are given. So final internal energy would be 450 R minus initial 2250 R. This will come to minus 1800. So the gas is losing energy, its internal energy is decreasing, and the work done by the gas is 1800 R. This work, which is done in process 1, is equal to the work done in process 2. And in the process 2, the internal energy of the gas is constant. And we know that internal energy of an ideal gas is a function only of temperature. So temperature is constant, which means it's a isothermal process. So for the process 2, we need it's happening at a same temperature, and we need to calculate that temperature. It is different from 900 Kelvin. So we know that U is NCVT and N is 1, CV is 5 by 2 R given. So from the value of U by R, which is 450, we can calculate the temperature. So 450 equals N is 1, CV is 5 by 2 R, 450 R is equal to 5 by 2 R and T. So T is 450 times 2 by 5, which will be 180. So the isothermal process is happening at T equals 180 Kelvin, and for an isothermal process, work is minus PdV, PV equals nRT, and temperature is constant, which means P can be represented as nRT by V as a function of volume, and nRT are constants, so they come minus nRT, and integral dV by V, this will be minus nRT ln Vf minus Vi. And from the graph we can see that N is 1 minus RT is 180 ln V3 by V2. This is equal to the work done in the first process, which is minus 1800 R. So minus 1800 R is equal to minus 180 R ln V3 by V2, and we get 180 by R 10. So ln V3 by V2 is 10.